Okay, welcome everyone. In this video today I'm going to explain a little bit about exercise 7F. So 7F, we're looking at problem solving using parabolas. Let's say problem solving with parabolas. Okay, so problem solving with parabolas is what we're looking at. And in order to do problem solving with parabolas, we need to understand what the features are of a parabola. This is something that we've looked at in class already, but I'm going to explain them quickly here. So the features of a parabola . Okay, so let's draw a parabola graph. Okay, so if that's our parabola graph, there's a number of features. The first one is this point here. It's known as our turning point. Next we've got this point here, that's an x-intercept. This one here is a y-intercept. And last of all, this point here is another x-intercept. So we've got 4 points there already. We've got two x-intercepts, we've got a y-intercept, and we've got a turning point. Now the question is, what is a y-intercept? A y-intercept is where our graph goes through the y-axis, so where both those two lines meet. And similarly, an x-intercept is when our graph goes through the x-axis, which here happens on two occasions. The turning point is when our graph changes direction. So it was heading downwards, still heading down, slowing down, and then at this point it starts heading back up again. So our turning point is where it changes direction. Now, there is one other feature of this graph, and that is the shape. This is a positive shaped graph. Alright, so it's a positive shaped graph, and we can remember that because it looks a little bit like a smiley face. If we drew eyes, we can see it's very similar to a smiley face shape, like this. A negative shaped graph would just be exactly the same shape flipped upside down. So a negative shape would look like a sad face, obviously without the eyes, but it would look like a sad face. So they're all the features of a parabola graph. There are some other features though that we need to realize when we're doing problem solving. And I'm going to go through some of them now. The first one is we need to be able to work out the distance between my x-intercepts. So we need to be able to work out the distance between my x-intercepts. That's going to be important when doing problem solving. We also need to work out that height. So how do we refer to that? We might refer to that as the distance between the x-axis and the turning point. Okay, so just to emphasize, all the things I've done in black, they are features of a parabola, and all the things I'm doing in red, they are things that we need to look at when we're doing problem solving with parabolas. So the first one was distance between my x-intercepts. The second one is the distance between my x-axis and the turning point, so this vertical distance here. Another thing we might look at is we might actually look specifically at the x-intercept. So the values of the x-intercepts. Now, when we're talking about x-intercepts, you'll notice here that in this case, in this example, there are two x-intercepts. Two x-intercepts. One is negative, one is positive. What do I mean by that? Well, if I look at the coordinate, now I don't have a coordinate here, but if I was to look at the coordinate of this point, it has a positive x value because it's on the right-hand side of the y-axis. It's in the positive x direction. This x-intercept is actually on the negative part of the x-axis. Even though we don't know the coordinate, it's on the negative part of the x-axis because it is left of this y-axis. So it's on the negative part of the x-axis, therefore it is a negative x-intercept. Now we need to take careful note of this because normally we only want the positive. So I'll just make an asterisk here. Normally in problem solving, we only want the positive value. Positive x-intercept. Okay, normally we only want the positive one, sometimes the negative one, but not normally. So we've looked at the distance between my two x-intercepts. We've looked at the height difference between the x-axis and the turning point. And then we've also looked at which x-intercept we're interested in, and normally it's the positive one, the one on the left. And the last thing we haven't looked at is the y-intercept is sometimes important as well. So understanding what the coordinates of the y-intercept are, and in particular the y value of the y-intercept. So now we're going to look at not just the features of a parabola, but we're actually going to look at how they relate to the equation of a quadratic or a parabola. And this is important because we've got to be able to solve quadratic equations, graph them, and then look at the graphs to solve real-world problems. So let's just look, excuse me, let's just look at a quadratic equation. Okay, so I just want to point out here that a parabola is basically the shape of the graph. That is what you get when you draw a quadratic equation on a graph. So they're the same thing. The quadratic equation is the algebra, what it looks like with algebra. Parabola is what it looks like on the graph. Just pointing that out. So let's look at a quadratic equation. Y is equal to x squared plus 6x, and let's do plus 5. So y is equal to x squared plus 6x plus 5. If we were to look at this, we can quickly find the y-intercept. How do we find the y-intercept? Well, it's just this plus 5 on the end. So I get my y-intercept is equal to 0, 5. If I wanted to find my x-intercepts, I need to factorize this equation. And if I want to find the turning point, I need to complete the square. So let's do completing the square. To complete the square, I take the number in front of x, which here is 6, and I divide it by 2, which in this case gives me 3, and then I square that number, so 3 squared is equal to 9. Now, the way that I complete the square is I take my original equation and start writing it out. So y is equal to x squared plus 6x. Then I look at this number here that I just worked out, the number 9, and I'm going to add 9, minus 9, and then this plus 5 that was in my original equation comes back here. So just to point out, this line here is the same as my original equation, but I've just added 9 and then subtracted 9 in the middle of it. If you think about it, when I add 9 and then subtract 9 straight away, that just doesn't change the value of my equation at all, because plus 9 minus 9, that equals to 0. Just those two terms. And the reason I do this is because I want to easily be able to factorize the first 3 terms in this new way that I've written it out. And if I add 9, I can easily factorize these first 3 terms. If I didn't have 9 and I just went with x squared plus 6x plus 5, it's a little bit harder to factorize. I've got to do a bit more work. Whereas if I put this plus 9 in here, then I can factorize the first 3 terms easily, but I've got to remember to minus 9 because I want this equation to have the same value as this equation. So if you don't understand what I just said, please send me a message and I'll explain it again. But let's keep going. So I want to factorize these first 3 terms. Now I know that's going to look something like y is equal to x plus something squared. What number goes in here? Well, it's got to be a number that when I double it gives me 6, and when I square it gives me 9. Well, we know that that's 3 because we've got 3 here. So 3 plus 3 gives me 6, and 3 times 3 gives me 9. So I can easily factorize these 3 terms to this by looking at that 3. Then the last 2 terms, minus 9 plus 5, that just gives me minus 4. So this, at this point, I've completed the square. So this is turning point form. So I can find my turning point by looking at this 3 and that minus 4. Now, my turning point actually has a value of -3, -4. The reason it's -3, -4 is whenever we've got something in brackets like this, so x plus 3 squared, we need to, when we take this number outside, we need to take the minus sign of it. And the reason is because we've got x plus 3, and we've got to consider how does that relate to x? Well, we've decreased the x value by 3. So if x was -3, then everything in the brackets equals 0. That's why we take the -3 instead of +3. But this number is not in brackets, so we just leave it as -4. So that's our turning point. And if we wanted to fully factorize it and find our x-intercepts, we need to use the difference of 2 squares. So using difference of 2 squares, we can write this as y is equal to x plus 3 squared minus 2 squared. You notice that 4 is the same as 2 squared. And now because we've got one squared term minus another squared term, we can factorize it. So this becomes y is equal to x plus 3 plus 2 times x plus 3 minus 2. Now what did I do? Well, x plus 3 is the same in both of my new brackets. In one of the brackets I added 2, and in the other bracket I minus 2. And if you look at minus 2 times plus 2, that gives me minus 4, essentially. So I take this 2, which is being squared, I take the 2, I add it to one bracket, and I subtract it from the other bracket. And now I can just simplify this. Y is equal to x plus 5 times x plus 1. And this is factorized form, so I can actually find my x-intercepts. Okay, so my x-intercepts are, I'm going to have two x-intercepts because I've got two different brackets. And the same thing that we did with turning point, any number in a bracket, we minus it when we're taking it out of the bracket. Same thing we do here. So x plus 5, that means that my first x-intercept is minus 5, 0. And my second one, x plus 1, so my second x-intercept is minus 1, 0. And you can see there, again, I'm just pointing out that it's minus 5, where in the bracket we had x plus 5, because minus 5 plus 5, this whole bracket goes to 0. And it's minus 1 for this bracket, because minus 1 plus 1 makes this whole bracket equal 0. So that's how we do completing the square to get to here. So completing the square gives us the turning point, and then we use difference of two squares to fully factorize it to get x-intercepts. I just want to point out here, once we've completed the square, if this sign between my two terms, if this sign is a plus sign, I cannot factorize it any further. And that's going to mean that there are no x-intercepts. So just say that again. Once I've completed the square and got to this version where I've got x plus 3 squared minus 4, if this is a plus sign, so if it was plus 4, I can't factorize it any further, and that means that there are no x-intercepts. Okay, so everything we've looked at so far is we've looked at the features of a parabola, we've looked at a quadratic equation and how to find those features from an equation. But remember, if we go back to the top of our page, we're trying to look at problem solving with parabolas. Now, if we're looking at problem solving with parabolas, we're looking at all these features in red and things that I've underlined and so on. And we want to look at them in a real world problem. So in the next video, I'm going to show you how we solve problems. I'm actually going to look at two problems from the book and how we solve them using everything we just described here. So I'll see you in the next video.